What if 3I Atlas isn't just a rock from another star, but an alien probe in disguise, quietly flying through our solar system while we watch it like clueless bystanders? A hidden machine wrapped in ice and stone, taking a close look at us before vanishing back into deep space. In this video, we're going to take that idea seriously. Not as clickbait, but as a thought experiment. If 3I Atlas really were an alien probe, what would we expect to see? And how does that compare to what we actually know? 3I Atlas is our third confirmed interstellar object, a visitor from beyond our solar system. Its orbit is hyperbolic, meaning it's not bound to the Sunday. It came from far away. It's diving through our neighborhood once, and then it's gone forever. As far as mainstream astronomy is concerned, 3I Atlas is a natural fragment. Maybe a comet Faye-like body, maybe more like an asteroid that was kicked out of some distant star system long ago. Right now, there is no hard evidence that 3I Atlas is artificial. No unexplained radio signals, no proven course changes, nothing that forces us to say, this must be alien technology. The safest assumption is that it's just another rock. But asking, what if it isn't, is useful because it forces us to think about how we'd even recognize an alien probe if one flew right past us. So, here's how we'll explore this. First, what we actually know about 3I Atlas. Then, what a realistic alien probe might look and act like. After that, we'll compare that picture to the real data and see where the idea holds up and where it falls apart. And finally, we'll ask what this tells us about how to search for alien technology around us. Let's start with the basics. When astronomers discovered 3I Atlas, the first clue that it was interstellar was its orbit. Plot its path through the solar system, and instead of a neat ellipse like a planet or a bound comet, you get an open curve, a hyperbola. In simple terms, it's moving too fast and at the wrong angle to be captured by the Sunday's gravity. It came from outside. It will swing by once, and then head back out into the galaxy. From how bright it appears at different distances, and how that brightness changes, scientists can estimate its size and something about its surface. The details are still being refined, but we're talking about an object probably on the order of hundreds of meters to maybe around a kilometer across, dark like many comets or asteroids. Unlike its famous interstellar cousins, ʻOumuamua, with its strange shape and brightness changes, and comet Borisov, which looked more like a normal comet, 3I Atlas seems, so far, to fit reasonably well in the weird but natural category. Nothing in its motion absolutely screams artificial. Its path matches what you'd expect from gravity acting on a fast Faye-moving rock. We haven't seen dramatic non-Faye gravitational accelerations, and there are no confirmed signals or pulses coming from it. That's the observational baseline. Now, let's imagine the other possibility. Suppose 3I Atlas isn't just a rock, but a probe, an unmanned, automated spacecraft built by some distant civilization. What would that actually mean? In science fiction, alien ships are often huge, noisy, and obvious. In reality, if a civilization wanted to explore the galaxy efficiently, it might send out countless small, durable probes designed to work for millions of years. Think of them less like star destroyers, and more like extremely tough, smart space probes. Something in the spirit of our own Voyager spacecraft, but far more advanced. Their job could be simple: fly through star systems, map the planets and asteroids, sniff out signatures of life and technology, maybe drop off tiny sensors, then report back, either directly or through a network of relay stations scattered through the galaxy. If you wanted your probes to survive for eons in a dangerous universe full of radiation and random impacts, you might do something clever. You might build them to look like ordinary space rocks. A probe disguised as an asteroid or comet would automatically have a protective shell of rock and ice. It would be hard to distinguish from the countless natural objects that already exist. You could even imagine an advanced civilization seeding a galaxy with these camouflage scouts, each one blending into the background while slowly gathering data. But to function as a real probe, it needs certain things. It needs power, maybe a very efficient nuclear source, maybe a way to harvest starlight, or something far more exotic. It needs instruments to sense magnetic fields, atmospheres, infrared signatures, or radio noise from technological societies. It needs some form of memory to store data, and some way, slow and patient though it might be, to send that data home, or to the next node in the network. Given all of that, could something like 3I Atlas be a disguised probe? To answer that, we need to think about how an alien probe would behave differently from a purely natural object, because that's the only way we'd catch it. The disguise may be perfect to the eye. The differences might show up in the motion and emissions. Start with the orbit. A natural interstellar rock follows a trajectory determined almost entirely by gravity. The pull of the Sunday, the planets, and nothing else. If we measure its position over time, fit an orbit, and everything lines up with physics, that's a good sign. It's just a rock. A probe, on the other hand, might adjust its course, even slightly, firing tiny thrusters, using some sort of advanced sail, or making deliberate changes to maximize what it can observe. These course corrections wouldn't need to be dramatic. In fact, if you're trying to remain unnoticed, they probably wouldn't be. But if they were there, we might see subtle deviations from a pure gravitational path, accelerations that don't match outgassing, that don't fit a simple comet model. Next, rotation. Natural objects tumble. They spin in awkward, often chaotic ways, speeding up or slowing down as they are heated unevenly by the Sunday, or as jets of gas push on them. Their brightness, as we measure it from Earth, tends to rise and fall in irregular patterns as they rotate. An engineered probe might have a more stable spin, or adjust its orientation deliberately to keep instruments pointed at targets. That could create more regular, repeating brightness patterns, almost like a lighthouse beam sweeping past. Then, there's the question of emissions. Natural objects mostly reflect sunlight and, if they're cometary, glow from gas and dust driven off by solar heating. They don't, as far as we know, produce narrow Faband radio signals with repeating patterns. A probe, even a stealthy one, might sometimes communicate short bursts of radio or laser light, or unusual, structured emissions that don't look like natural astrophysical sources. Astronomers and SETI researchers know this, and they do look when a strange object like ʻOumuamua or 3I Atlas shows up. Telescopes often check not only its position and brightness, but also listen for possible radio transmissions. So how does all this compare to what we've actually seen from 3I Atlas? Based on the observations so far, its orbit fits a normal interstellar path. The gravitational pull of the Sunday and the planets explains its motion well. There are no confirmed, unexplained accelerations like the ones that spark debate around ʻOumuamua. If there are non-Fe gravitational forces acting, like faint outgassing from ices turning to gas, they seem to be within the range of what you'd expect from a natural object. As for its brightness and spin, any variations so far look consistent with a small, irregularly shaped body rotating in sunlight. We don't see a bizarre, laser, Fe-like pulse, or some repeating pattern that screams artificial beacon. Radio telescopes have the capability to check for signals from targets like this. In the past, when ʻOumuamua passed through, facilities like the Green Bank telescope were used to listen for artificial transmissions. Nothing convincingly artificial was detected. With 3I Atlas, the story so far is similar. No obvious radio chatter from an onboard transmitter. Put all that together, and you get a picture that is frankly not very satisfying if you want aliens. 3I Atlas behaves exactly like a natural piece of interstellar debris, and nothing in the data so far forces us to consider an artificial origin. This is why most scientists apply what's known as Occam's razor. Don't multiply explanations beyond necessity. If a simple natural model explains what we see, gravity, ice, rock, sunlight, there's no need to jump to an alien probe. That doesn't mean it's impossible. It just means the evidence doesn't demand it. And extraordinary claims require extraordinary proof. But here's the important part. Dismissing 3I Atlas as just a rock doesn't mean the alien Fe probe question is pointless. On the contrary, thinking carefully about this scenario helps us design better ways to look for technology in space. There has already been serious, if controversial, Discussion about objects like ʻOumuamua possibly being artificial, with researchers like A.V. Loeb arguing for more open, fair-minded consideration of that possibility. Even if you disagree with those specific claims, the broader point stands. If intelligent civilizations exist, sending out robotic probes is one of the most efficient ways for them to explore a galaxy. And those probes might not want to be obvious. Some scientists have even proposed the idea of lurkers, alien devices quietly parked in stable orbits around planets, moons, or asteroids, watching and waiting. Others suggest that interstellar probes could be embedded in or disguised as natural fey-looking rocks, exactly like we've been imagining for 3I Atlas. Combine that with the Fermi paradox, the question of why, in such a large and old galaxy, we haven't clearly seen any signs of other civilizations. And you can see why every interstellar visitor gets people thinking. Maybe probes are common, but subtle. Maybe we've been looking in the wrong places, or with the wrong expectations. So what does 3I Atlas teach us, even if it's just a rock? First, that we need to be ready to observe these objects, as early and as thoroughly as possible. The biggest limitation with ʻOumuamua and other interstellar visitors has been time. We detected them relatively late when they were already screaming through the inner solar system and on their way out. That left only a short window to measure their properties. As sky surveys improve and new telescopes come online, like the Vera C. Rubin Observatory, we should start spotting interstellar objects earlier, when they're still farther out and moving more slowly across our field of view. That gives us more time to point big telescopes at them, to measure their spin, brightness, composition, and yes, to listen for any unusual signals. Second, there's a growing conversation about sending spacecraft to meet the next one. Imagine a ready Fei launch mission sitting in space or on standby on Earth, designed specifically to intercept and fly by the next interstellar visitor we detect. It could carry cameras, spectrometers, magnetometers, and radio receivers swooping in to get close Fei-up images and direct measurements. If by some wild chance one of these objects actually were a probe, this is how we'd find out. And third, the idea of 3I Atlas as an alien probe forces us to refine our definition of what counts as a technosignature, a sign of technology. It's not just radio signals from distant stars. It might be unusual orbits, anomalous accelerations, strange reflections, or artificial materials on the surfaces of otherwise natural Fey-looking bodies. Once we know what to look for, we can feed those criteria into our surveys and data analysis. So where does that leave our original question? If 3I Atlas were an alien probe in disguise, we'd expect at least some hint of unnatural behavior, odd trajectory changes, highly regular or controlled rotation, unexpected emissions. So far, we don't see that. Everything we know about it fits comfortably inside the boring, but real category of interstellar debris. Could an ultra-Fey advanced civilization build a probe so perfect that it leaves almost no trace at all? No signals, no maneuvers. Nothing that our current instruments can detect. Of course, at that point though, the idea becomes impossible to test, and science deals best with ideas that can be checked against reality. The honest conclusion is this: 3I Atlas is almost certainly natural, but using it as a thought experiment has value, because it helps us sharpen the tools we'll use on the next visitor. And the next, and the next. One day, an object might arrive that refuses to fit any natural explanation we know. When that happens, we'll want to be absolutely sure we've asked the right questions. If this video helped you think more clearly about the difference between a wild theory and a testable idea, about how we'd actually recognize alien technology if it flew past us, consider subscribing to the channel. I'm creating a full series on 3I Atlas and other interstellar what-if scenarios, taking the crazy questions and walking them through real physics and astronomy. Tell me in the comments, do you think any of the interstellar objects we've seen so far could be artificial, even in a tiny chance? And if we had one shot to send a probe to the next visitor, what instrument would you put on it first? Because this story doesn't end here. We've talked about 3I Atlas as a possible alien machine. But what if objects like 3I Atlas carry something far simpler and far more patient than technology? What if they carry the ingredients of life itself, seeding planets across the galaxy. In the next episode, we'll explore what happens if interstellar rocks become the messengers that spread life from star to star.